Okay, so today we're going over the quadratic formula. So remember, when you're solving quadratics, there's 5 ways you can solve a quadratic. You can graph it and look at the x-intercepts because the x-intercepts are the solutions. You can solve by factoring with the zero property. You can solve with algebra and the square root property. Or you can use completing the square. Or you can use the quadratic formula. On the quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. The b squared minus 4ac, so the b squared minus 4ac part, that's called the radicand. The number that's under the square root is the radicand. So the b squared minus 4ac part is called a discriminant. So that part of it is called the discriminant. The quadratic formula, finds your x-intercepts. So when you solve, you find the x-intercepts. That's also the solutions. They're also known as zeros. They're also known as roots. So when you use the quadratic formula, you are finding the solutions or the x-intercepts or the zeros or the roots. The discriminant will tell you what kind of roots you get or what kind of solutions you get. So it will tell you how many solutions, and it also will tell you what type of solutions they are. So for an example, if the discriminant, remember, which is b squared minus 4ac, if the discriminant is less than 0, in other words, if the discriminant turns out to be a negative number, right? Anything less than 0 is a negative number. So if the discriminant is negative, that means you'll have no x-intercepts. There will be no real solutions because there will be 2 complex or imaginary solutions. So sometimes we refer to imaginary solutions as complex solutions. So you just say imaginary as well. So notice that this parabola does not touch the x-axis, so it has no x-intercepts. Therefore, it has no real solutions because it has imaginary solutions. If the discriminant, remember that's the discriminant, if the discriminant comes out to be exactly 0, that means the vertex is going to be right on the x-axis. So there's going to be one x-intercept. And therefore it will be a real, because it's not imaginary, because it actually touches the x-axis. So it has an x-intercept. So it's real, and it's going to be a rational solution. So a real rational solution. So the discriminant will tell you how many solutions, right? We had 2 and they were imaginary. So it'll tell you how many and what type they are, right? So if it equals 0, you will have 1 solution and it will be real rational. If it's greater than 0, so if it's greater than 0, that means if it's positive, right, you will definitely have 2 solutions because it'll definitely have 2 x-intercepts. But it depends. They'll both be real, but it depends on whether it's rational or irrational. So if the b squared minus 4ac comes out to be a perfect square number, then they will be real rational. If it comes out to not be a perfect square, like the square root of 3 or 4 radical 5 or 6 square root 7, if it's not a perfect square, right? So if it's not a perfect square, in other words, that there's still a square root, then it would be considered real and irrational. So when you have a positive number, when the discriminant is positive, you will definitely have real solutions. But what type of real solutions? Are they real rational solutions or are they real irrational solutions? So when it's a perfect square, they will be rational. And when they're not a perfect square, in other words, when you have a square root. So that's your discriminant, will tell you how many and what types. So now we're going to actually use the quadratic formula to solve a quadratic, to find the solution, or to find the x-intercepts, or to find the zeros, or to find the roots. So in order to use the quadratic formula, we need to make sure that we can identify. So the steps are to rewrite in standard form, identify the A, B, and C, substitute into the formula, and then evaluate and simplify when appropriate. So those are our steps to using the quadratic formula. Try not to rush those steps. So the first thing you have to do is be able to identify the A, the B, and the C. So it has to be in standard form. So in number one, what's the A value, the B value, and the C value? So when we're looking at the A value, remember we're looking at ax squared plus bx plus c equals 0. So we want to make sure it's in standard form first. So we got to make sure it's in standard form first. So negative x squared minus 2x plus 3 equals 0, because we got to move that over. And then what are the coefficients? So the coefficient of x squared is -1, so -1 is my A. The coefficient of the linear term, right, this is the linear term, is -2, so -2 is my B, and the constant term is your C. So you have to be able to identify your A, your B, and your C correctly. So in number 2, identify the A, the B, and the C. Maybe pause the tape and see if you identified it correctly. So did you put 4 for A? Did you put -1 for B? And did you put C is 0? So remember, we have a coefficient of -1 for B, and there's no constant, right? There's no plain old C term. There's no constant, so you got to make sure you put 0 for C. The last one, 1/2 x squared minus 6 equals 0. Identify your A, your B, and your C. So did you put 1/2 for your A? Don't put 1/2 x. And then notice there's no linear term. So we have 1/2 x squared plus no linears minus 6. So be careful. There are no linear terms. The x is the linear. So did you put 0 for B? And you put -6 for C? So you have to make sure that you identify the A, B, and the C correctly first before you can start using the quadratic formula. Okay, so number 1, solve and identify the types and number of solutions. So the first thing we're going to do is solve. So step 1 is to rewrite it in standard form first. So let's go ahead and move everything over to the other side. That gives me 5x squared minus 18x plus 13. Don't forget to put equals 0 because it's an equation. Then you need to identify the A, the B, and the C. So in this problem, the A is 5, right? The A is 5, the B is -18, and the C is 13. And then remember, the formula is -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we're just going to recopy the formula. And so we identified. Now we're going to substitute. When you substitute, it's super important. For the substitution method or step, we are not solving anything yet. We got to do that first before we evaluate. So don't get ahead of yourself. So first, just, right, we've got a negative and then b, and b happens to be a -18, plus or minus. A lot of people forget the plus and minus. And then you have to put a parentheses here, -18 squared, because it says b squared. You must have a parentheses there, minus 4 times a times c. And that is all divided by 2 times a, right? So the very first thing is you need to make sure that wherever there is a b in the problem, that you're putting -18 where the b used to be, using the correct parentheses and notation. Super important that you're using that notation, right? And then we have our a. Make sure that you put the a in the right spot, right? And then you've got your b. Make sure you put your B, or C, sorry, your C. Right, so use the correct notation. So that's the first step. Now we need to start evaluating. So we substituted, now we need to start evaluating. So when you evaluate, I always take care of and simplify signs. So negative times a negative is +18, plus or minus 2 times 5 is 10, and then we need to figure out what's underneath the square root. And remember, what's underneath the square root is called the discriminant. So all of this part is the discriminant. So let's see, what is -18 squared minus 4 times 5 times 13? Right, so -18 squared is, so -18 times -18 is 324. So you might have to work that out, right? And then now we have to do 5 times 4 times 5 is 20, and then 20 times 13, right? So 13 times 2 is 26 with the 0, so that's minus 260. And then 324 subtract 260, I'm going to count up, so another 40 to 300, that'd be 64. So my discriminant is 64. So what's underneath the radical is 64. So I like to kind of do the discriminant. If it's a little bit difficult, I like to do it outside. Let me clean this up a little bit, right? So the discriminant was negative 18 squared minus 4 times 5 times 13. And when you do the negative 18 squared, minus is 64. Now we can go ahead, once I figured out the discriminant. So notice the discriminant is a perfect square. So remember what we just talked about earlier? So the fact that the discriminant is a perfect square, that's interesting. See if I can write over top of this. So the discriminant is 64, which is a perfect square. So that means we're going to have 2 because it's positive, right? So the discriminant was positive, so we know we're going to have 2 real solutions because the discriminant was positive, right? So it was positive. So we know it's 2 real. But is it 2 real rational or 2 real irrational? So the fact that it was a perfect square, that means we're going to have 2 real rational roots, right? So I know for sure I'm going to get 2 answers, and I know they're going to be real because it's not, right? It's positive. And because it's a perfect square, it's going to be rational. Okay, let's finish it up. So we've got 18 plus or minus. Square root of 64 is 8 divided by 10. And then remember, this means 18 plus 8 divided by 10 and 18 minus 8 divided by 10. So my 2 answers are going to be 26 tenths. So reduce that. 2 goes into that 13 times and 2 goes into 10 5. So always reduce. And this is going to be 10 over 10, which is going to be 1. So those are my 2 answers. Okay, and if you can do this part in your head, right? If you can do this part in your head, good for you. If not, sometimes I can. Depends on if the numbers are too big or not. And then get my answers. Okay, so let's look at some more quadratic formula problems. Okay, so solve by using the quadratic formula. So you need to memorize the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, 4 times a times c, all divided by 2a. And remember, the quadratic formula finds the solutions, which are the x-intercepts, which are also called the roots, which are also known as the zeros of the function. In order to use the quadratic formula, you first have to put it in standard form. So that's going to give you negative 2x squared. Remember when we were factoring, we said it's always a good idea to have the quadratic term positive. With the quadratic formula, it doesn't matter if the leading coefficient is negative or positive, right? It doesn't really matter because you're just using a formula. But when you're factoring, it's always smart to have that be positive. So I just want to mention that. And then identify the a, the b, and the c. So I'm going to identify the a and the b and the c over here. A is negative 2, b is positive 4, and c is 1. And then the second step is to plug into the formula. So we've got our negative b. B is 4 plus or minus the square root b squared minus 4 times a times c. And all of that is divided by 2 times a. Super important. A lot of kids throw in the denominator at the very end. Write out the entire sentence completely. Like, don't leave the denominator out. So a lot of kids will, they'll leave this out and they'll throw it in at the last minute. Put it in there at all times. So now let's check the discriminant. So let's simplify and let's figure out the discriminant. If you can do the discriminant in your head, great. Otherwise, I like to kind of pop it out. Make sure no calculator. So you guys should not be using any calculator. So we've got negative 4. We got negative 4 plus and minus. 2 times negative 2 is negative 4. Be careful. A lot of students, when they're writing the formula, they will forget the plus and minus. And maybe they got it here, but then when they recopy it, they leave it out. So don't leave that out. And then the square root, and then let's check the discriminant. So the discriminant is 4 squared minus 4 times negative 2 times 1. So 4 squared is 16, and then a negative. Okay, and then a negative times a negative is a positive 8. So 4 times 2 times 1 is a positive 8, and then that equals 24. So our discriminant is 24. And because it's positive, that means we have two real solutions, and it's not a perfect square, so that means they're going to be irrational. So we've got to simplify, so we'll come down here. So negative 4 plus and minus. Square root of 24 is, right, square root of 24 is 4 times 6. So that's 2 square root 6 over 4. And since all three of these have something in common, you must reduce by 2. So our answer is negative 2 plus or minus. Oh, that should have been a negative 4 right there. So let's reduce by so let's divide by a negative 2, because that'll clean up our negative signs. So let's divide by a negative 2. So that makes that negative divided by a negative, right? When I divide by a negative, that's going to make that positive 2. And when I divide this by a negative, it's the plus and minus stays the same. So that's going to be square root of 6. And when I divide a negative 4 by a negative 2, right, that's going to give me a positive 2. So that kind of cleans it up a little bit. So that's your answer. And notice, because we have a square root symbol, right, that's why it gives us two real, and because of the square root symbol, that's why we get the irrational. Because the square root of 6 is a decimal that goes on forever and ever and ever with no repeating pattern. And that's the definition of an irrational number. Okay, and then let's look at number 3. So we want to put it in standard form. So 2x squared minus 6x plus 9 equals 0. Identify your A is 2, your B is negative 6, and your C is positive 9. So it's negative 6 plus or minus the square root of negative 6 squared minus 4 times A times C, all divided by 2 times A. So that's 6 plus or minus, and what's the discriminant going to be? So it's 36 minus 4 times 2 is 8. 8 times 9 is 72. So my discriminant comes out to be negative 36. So since my discriminant is negative, that means we're going to get two imaginary solutions, and sometimes we call those complex. So complex solutions are going to be imaginary. So we have to simplify. So that gives me 6 plus or minus 6i divided by 4. And we got to reduce by 2. So all three are divisible by 2. So that gives me 3 plus or minus 3i divided by 2. So we have two imaginary solutions. Okay, last problem, number 4. Okay, number 4, we have our A is negative 3. Notice our B is 0. And our C is negative 2. So remember, it's ax squared plus bx plus c equals 0. And our linear term is our b. And notice we don't have a plain old x term. So our b is 0. So it's 0 plus or minus the square root right? And then don't forget, all divided by 2 times negative 3, right? And our discriminant is going to be 0 minus 4 times negative 3 times negative 2. So a negative times a negative times a negative comes out negative. So 4 times 2 is 12, times 2 is 24. So we've got 0 plus or minus the square root of negative 24 divided by negative 6. Once again, our discriminant is negative. Therefore, we are going to have two imaginary or complex solutions because the discriminant was negative. And then obviously 0 plus anything is just that thing, and so we've got plus and minus, and then square root of 24 is 2 square root 6 over, oh god, I forgot my I because there's a negative in there, isn't there? So we got to fix that. So we've got 2i because there's a negative, so I've got to make sure I have my I in my answer, and then we've got a negative 6. So to clean up this negative sign, if we distribute that negative sign up above, that's going to just turn that back into a plus minus. So it's 2i square root 6 over 6. So basically, we're moving this negative up here and we're distributing it. So a negative times a positive gives us that negative, and a negative times this negative gives us that positive. So when you distribute a negative and a positive to a plus minus, it doesn't really change anything. And if you want, you can write it out front. So you can write out front plus minus 2I square root 6 over 6. So as you can see, we have two imaginary complex solutions.